So we are now doing homework on 2.2, day 1. So let's look at number 46. So number 46 says it wants us to find the limit as x goes to 10 of f of x. What does it say? Which of the statements is true or false? So it says that this is equal to 0. Is that true? Well, as x gets closer and closer to 10 from the left, it looks like the limit as x goes to 10 from the left of f of x is equal to 0. And it looks like the limit as x goes to 10 from the right of f of x is equal to 0. So the limits agree, which means, yes, this is equal to 0 because the limits agree. So that's number 46. Then it asks number 47. So 47 says the limit as x goes to -2 from the right is 3. So as you go to -2 from the right, so as the inputs walk in from the right, so from the right would be from this side, but it looks like from the right it explodes up, so this would be false. The limit as x goes to -2 from the right of f of x is actually equal to positive infinity because it grows without bound. Okay, and I'm going to take this and I'm going to duplicate it. I'm going to take this. Let me erase some stuff. So we just did 47. So let's now do 48. The limit as x goes to -8 of f of x. Is that the same as f at -8? So what it wants to be and what it is, are they equal? So what the function wants to be is we go towards -8. So in this case, this would be false because they are not equal. No, they are not equal because the limit as x goes to -8 of f of x. So from both sides, it looks like the function, as we come in from both sides, it looks like the function wants to have an output of -6, but then f at -8, the output you get when you plug in -8 is -3, and those things are not equal. All right. Maybe it would look better if I did it this way. Boop, 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 equals -3. And so those are not equal. Not equal. And that was 48. And then we look at number 49. And what 49 is asking is the limit as x goes to 6 of f of x actually equal to 5? Well, as it comes in from this side, it looks like it wants to be 2. And as it comes in from this side, it looks like it wants to be 5. So this limit, this is false because the limit as x goes to 6 from the left is 2. The limit as x goes to 6 from the right is 5. And that means that the limit, have a good one, as x goes to 6 of f of x does not exist because, D and E does not exist because the limits don't agree. The left and right hand limits do not agree. So that's 49. Let's keep on going. So then we look at 50. So if I'm looking at 50, it wants to know the limit as x goes to 1 from the left. As we go towards 1 from the left, it looks like this function wants to be 1. Let's see. And 51 wants to know the limit as x goes to 1 from the right. As it comes in from the right, it looks like this function wants to be 2. So then if you ask me, for 52, what is the limit as x goes to 1? That's from both sides. So if I don't say from the left or from the right, it means both sides. And this does not exist because the limits the limits don't agree with each other. Because the limits don't agree, you do not have a limit. Then 53 for the same picture. It says, what is the limit as x goes to 2 of f of x? So as the inputs get closer and closer to 2 from either side, looks like the outputs get closer and closer to 1. So that's 1. Well, then it asks for 54. It says, what is f when you plug in 1? When you plug in 1, it looks like the output you get is 1. All right, so that's 54. Now I'm going on to 55. So 55 says, what is the limit as x goes to 0 from the left? As you come in with inputs from the left, it looks like the outputs get closer and closer to 1. And 56 says, as the inputs walk in from the right, does the function tend towards something? Yes, as you walk in from the right with inputs, the outputs get closer and closer to -4. And then 57 asks the next logical question, is there an overall limit? Well, no, this limit does not exist. And the reason is because the limits don't agree. It doesn't want to be the same thing from the left and the right, so you can't say it wants to be one thing. So 58, the limit as x goes to 2 of f of x. Well, as we walk in from the from the left, this function wants to be 0. As we walk in from the right, the function wants to be 0. So I guess this would be 0. That's 58. So then we go down to 77, and it wants us to create a function with a whole bunch of really cool properties. So if we look at 77, it's saying I need a function that as x goes out to -infinity, it wants to go to 0. So that means as you go further and further out this way to -infinity, it eventually wants to be 0. Well, I'm just going to have it do this and get closer and closer to 0. That would show that the limit as x goes to -infinity of f of x is equal to 0. Then it says as you get closer to -1 from the left, it wants to go to -infinity. So I'm actually going to have my graph do this. So I'm going to have it go to 0 this way. But then as I go to -1, it wants to go to -infinity. So the limit as x goes to -1 from the left is -infinity. That just means that there's a vertical asymptote there. Then, as you go towards -1, as x goes to -1 from the right is +infinity, just means that it blows up there, right? But then it says that, so let me erase this. Poop. Erase this just a little bit. So I need it to explode here, but then it says that f of 0 is 1. So f of 0 is 1, and more importantly, the limit as x goes towards 0 from both sides is equal to f of 0. That means it is actually 1. So it wants to be and is 1 from both sides. And then it says, as x goes to infinity, y goes to -infinity. So this would say the limit as x goes to infinity equals -infinity. That means that it just explodes down in the long run. Cool. And the last one is 81. So you've got a function, and I'll take a picture of 81 because it's a pretty cool picture. So if I'm doing 81, let me do this. Bloop. Say done, save to photos. Go back over here to my other app and plug in 81. So 81, poop. Okay, so here's 81. So here's some shock waves. ranging from supernovas to detonation waves. So everything is fine, and then kablamo, it goes down. So that would be a case of a shock wave, right? So a graph of the density of the shock wave with respect to its distance, x. So here, the shock wave has this density, but then you have the front of the shock. So the shock hits you right here if you're this far away. So right here, you feel it, but as soon as you step over here, it has a much less lower intensity and you don't feel it as bad. Maybe you're behind a building. So if you're on one side of the building, you really feel it. Here, you have this shock wave where it really is almost like not a function. The function does not exist at that point. So the limit as x get closer to that front of the shock wave, we'll call it x of SF. That's the front of the shock wave. So as you walk in from the right, it looks like the outputs want to be rho 2. Looks like it gets you rho 2, whatever that number is. And then it also says, as you walk in from the left, so the limit is x, so that's from the right. Seems the limit as x goes to your place right here called the front of your shock, or x sub SF, that rho, that density of that shock wave is rho 1. So as you walk in this way, it looks like it's always rho 1. And then for some reason at this point, it's just much lower on the other side. Again, maybe there's a building blocking the shock wave, where on one point you really see this big difference. Or maybe it's like this huge wall or something, right? So we would say that the limit as x goes to x sub SF does not exist because why? Well, we said it time and time again, the limits do not agree. What it wants to be from one side is not the same as what it is from the other side. So if there was some sort of a detonation and explosion, then at all these points, like maybe here's where the explosion is. At some time I snap a picture and everybody if you're this close, felt the shock wave, but if you're over here, you wouldn't feel it. And as time goes on, you would expect that further and further away, we would feel a shock wave. But maybe this is just, there was just an explosion and I stopped. At this instant, if you were within this blast radius, you feel the shock wave, but if you're outside, you barely feel anything. But then as time moves on, you can imagine that this distance would get further and further, right? And again, physically, maybe there's a wall where if you're on this side, you're on the other side of the wall, so you don't feel it as bad. But great work, keep it up, bye.